All right, now we have Grant, who's going to be talking about OpenStack Security. Grant works for Red Hat. I believe you're a local?
Yeah,
Yep.
local from Brisbane.
So you can ask him where's good to go get dinner. But, yeah, Grant.
Lots of places. We'll talk afterwards. Yeah, well, we can do that if you like. I'm here today, guys, to talk about the OpenStack security. It's an important issue as a lot of people are trying to move towards the cloud. People are concerned about the security issues that are around in cloud. I purposely set the topic for today's talk pretty vague and hand-wavy, just so that depending on how much I could fit in the time slot, the number of items that I'd cover. What I'm going to look at mostly covering today is the vulnerability management process. So if a security issue is reported to OpenStack upstream, how it's managed, and how we protect cloud operators and cloud vendors that ship derivatives of OpenStack software from being exposed to risk. I'm going to pull together some metrics that contain information about the types of vulnerabilities that we've seen historically in OpenStack and break that down a little bit. And since it's PyCon, I'm going to pull out a few mistakes that people commonly make in Python and try and hammer home the point that we really should stop seeing this kind of stuff coming across our desk. So as already been sort of said, I'm a software engineer at Red Hat Product Security. I don't solely work on OpenStack. I work on a range of different things that Red Hat ship, both proactive security initiatives and reactive. And I've actually been fortunate enough to be a member of the OpenStack vulnerability team since late 2013. And I'll explain what that actually means in a moment. So our team is basically held responsible for making sure that security problems get fixed in a responsible manner within OpenStack. Currently there's only 4 of us. Thierry, which I'm sure everyone who's got anything to do with OpenStack knows who he is, Jeremy, Tristan, and myself. Basically, we follow a process that is similar to what is the functionality of a cert and how they handle security issues within an open source project. And unlike most open source OpenStack projects, our only real output is not code, it's a security advisory. So this is what our process looks like. It's pretty well documented on that wiki page for those that are interested in knowing more about it. Essentially what happens when a security issue is raised and how you actually raise a security issue is by creating a bug in Launchpad, clicking the private security tag, or emailing us with a GPG signed and encrypted email. Basically, one way or another, that will notify all the members of the vulnerability management team that there's a problem with OpenStack code. From there, we generally try and triage the bug, try and figure out how severe it is, what projects it affects, what versions of OpenStack it affects, and if it requires some level of technical expertise, then that's when we engage the core security teams, for example, Nova and Keystone, or also on occasion engage with the OpenStack security group to try and figure out, is this issue something that's really an important security risk, or is it just a bug? From there, there's 2 main tangents. The members of the vulnerability management team go ahead and try and draft up a description of the issue that clearly indicates to vendors the severity and how their products will be affected. The developers then work concurrently to come up with a patch to fix this problem. Once the patch has been reviewed and approved, and we have an impact description, we request for a CVE, which is the way that the industry tracks security issues. From there, we have an embargo disclosure date that's set usually with around five days notice for key cloud operators and OpenStack software vendors. This allows them to apply the patches that we've worked through upstream into their products and make sure that they're not exposed to any security threats. At the date of embargo disclosure, that's when we open up the bug, push the patch up, and work to, as quickly as possible, get the patch merged and publish the OpenStack Security Advisory, which looks something like this. So the advisory contains all the information about what the vulnerability was, what versions of OpenStack it affected, references to Launchpad and the reviews for the fix. Interestingly, contains version information which might become a bit tricky if some of this semantic versioning comes into play. But yeah, it basically contains all of that information. And the vulnerability management team do that currently for all of those projects. I think there's about 24. And we make sure that any issue is backported for the previous 2 releases. But so that's basically our process. If you're interested in the security notification about these security advisories, you need to subscribe to one of these 3 mailing lists. If you're a Red Hat customer, for example, you will get your Red Hat security advisory as normal through the normal channels. But if you're interested in the upstream notifications, that's where you can find out about them. We also include that information in release notes, obviously, and that's another source of information for that. And finally, if you think that you should be eligible for advanced notification, that's the time when you should contact all of the members of the vulnerability management team and submit a proposal of why you need to have advanced warning about security issues. So I've been doing that process for a little while, and there's a couple of things that I wanted to point out that's not maybe well documented in the process that we have up on the wiki. First of all, when you raise a security bug or something as a private security issue, please don't muck around with the privacy of that issue after that point, because basically if you are unsure about it and then you change it to a public issue and then it actually should be something that should be handled privately, that's going to basically mean we have to fix it in a different manner and do it all publicly. So just leave that to the vulnerability management team to control that and decide if an issue should be public or not. Secondly, if you're one of those people that enjoy trying to find flaws in websites or get bug bounties, the vulnerability management team doesn't offer a bug bounty for any of OpenStack. We're an open source project, and that's not what we do, especially when you try and claim a bug bounty for something that is actually a website, not anything to do with OpenStack. That's not something we're about. And but we do give credit for people that find flaws in our products. And lastly, if you're actually fixing a security issue, it's the first time you've done it, the way it works is a little bit differently than the normal development cycle. So you can't just push up a fix to Garrett for a review, because just because the Launchpad bug is private doesn't mean that the Garrett review will be private, and that means that if you do that, everyone can see that information. And as you would know, if you're an OpenStack developer, that shows up in IRC logs, that shows up in email notifications and all sorts of things. So the way that we fix security issues is contained within the Launchpad bug at this time. So historically, we haven't done a very good job of keeping information about advisories in a structured format. So in preparation for this talk, I actually had to go back and pull all this information together and try and make some sense of it, because I know people would like to see some more statistical type information about the kind of vulnerabilities that we have in OpenStack. So what I came up with was a JSON format that encapsulated all that information in a structured way. And I can see moving forward the way that we'll manage vulnerabilities might try to take into account that format, and instead of manually drafting an email with all the advisory information, we might push a change up into an official OpenStack advisory project and have that be the trigger to send out an advisory. Some of the information is missing. I haven't gone through and actually assigned a CWE value, which is like basically a root cause analysis of the flaw or the chain of events that led to the flaw. And the information that I've got around impact is something that I've obtained from the Red Hat vulnerability database. That's where you can go and view my terrible web development skills and information about all the advisories that have ever been issued for OpenStack to date. And you'll note that there's a fair few to-dos in that area. Okay, so here comes the stats. This is all information that I've pulled from that effort, and as you can see, Nova and Keystone have got a fair few security issues in the past. It's not surprising that Nova has had that many security issues, basically because it's been around the longest, and Keystone, well, that's the keys to the castle, right? So if you're a security guy, you're going to try and pick that apart. So I think it's pretty representative of how much a project's really been beaten up by the teams that are trying to attack it. I will note that there's actually, the ratings here, important, moderate and low, have been assigned by a Red Hat security engineer for each of these flaws. And there's actually another rating which is more severe, which is a critical, that has not been applied to any of the flaws that have been assigned or found in OpenStack. So I went a bit further, and I just, instead of actually doing the proper CWE assignment for each of those issues, I've just tried to go through and lump them into rough categories of the types of flaws that we're finding in OpenStack. Overwhelmingly, the issues that we see repeatedly are things like denial of service, information disclosure, and just failures around applying access controls and authorization controls to the types of things that we're trying to do within OpenStack. So broken that down even further again to the top 3 projects, and what you find is not really surprising. Nova, it has had a lot more of denial of service type flaws found within it, as something that, you know, provides resources, and if there's any failure in logic to clean up those resources, or ways around it, people are going to use that to try and take advantage, and any time that they can do that can result in a denial of service to that service. Keystone, the majority of the flaws that we've found there around access control or authorization. I've lumped a few others into credential revocation failure. That's probably not really a very good category, but I guess it's trying to represent things like token expiration or token revocation that hasn't been properly applied. You could probably put that together with access control. And last but not least, Horizon. You can see there that most of the flaws that we've found in Horizon, which is OpenStack dashboard, are related to web-related issues. So that's not really a big surprise. So now I've got this data that I've all pulled together. I was also able to pull out and actually put together a list of all the contributors that have reported vulnerabilities to OpenStack. There's around 70 different people that have done that. And is anyone in this room? Yay, 2 guys. So thanks for doing that. It really helps improve the security of the OpenStack project, and I think, good work. People don't actually often get too many thanks for doing that. And since I was here, I thought another interesting graph might be to break that down or group it by company. There's a proportion of the people that have reported advisories that are unaffiliated with any particular company. But you can see here, what this graph clearly shows is the value that enterprise engagement in open source software really adds. Where like the 3 top vendors have basically reported over half of the vulnerabilities within that product. So I think that's quite interesting, and it shows that it's actually quite valuable. Okay, so I wanted to do something that was less hand wavy and less statistics type stuff. So since this is PyCon, I thought I better show some Python code. And I thought one thing that I hate, and it comes across my desk all the time, is stuff that could have been avoided if you actually just read the documentation. Documentation clearly says, don't do this. And time after time, people do. So let's go through some examples. This is the most recent example that comes to mind, and it's probably not something that everyone has seen before, but basically using the HMAC module, when you're comparing an externally provided HMAC to one that you've calculated, you need to use compare digest. You can't just go equals, because there's an attack where basically you can figure out through a timing attack what the actual signature should be. And basically it says it there in quite clearly that you should not do that.
So why doesn't equal do the right thing here and give you a different operator for it?
That's a good question, and maybe it does. Oh, sorry, I should sort of also say, Nick's not in the room to pull me up, but there is some things that have been fixed in Python 3, but I guess my point here is always you should adhere to what the documentation says. But yeah, you're right. Like it should really be overridden in that case. But essentially, the output is a byte string, or if you do a hex digest, it's just a string. So then, how do you know that when you move that around? Anyway, so this is the essence of the fix for that issue, was to get rid of the old comparative and introduce a constant time comparison function. Next one is my favourite. OpenStack has to shell out occasionally, and the majority of the time you don't need to supply a shell equals true when you're shelling out, and you especially shouldn't be doing that when you're not validating user input from an external source, because that's a security issue. An example of when that's happened is in this advisory, where essentially you, as a user, you were able to execute whatever you kind of wanted to as the glanced host user. It's a simple mistake to make, but like it says it clearly there. Well, I think it says it pretty clearly that you shouldn't do that. Now this is one I think is definitely fixed in the later Pythons, but just beware. So HTTP_lib actually, for the HTTPS connection, doesn't validate the server certificate supplied. So if I was going to sit in between the network connection, I could provide you any old dodgy certificate and you'd be like, okay, cool. And then you'd send me your traffic and it would be all visible to me. So it says it quite clearly there that it does not verify the server certificate. And there's been multiple occasions within the clients, I've called out this one in particular, where there has just basically been using HTTP_lib when you should use something else that actually verifies the server certificate. Now, I'm not a huge fan of XML, and you might have guessed from that quote I've placed there. But I think what's more, obvious from that warning provided in the Python documentation is that this module is not secure against maliciously constructed data, and you need to be aware of that, which led to the use of that module, for example, led to a number of flaws in different projects. This is one of them, and essentially the fix again was to not use that module, but to do it in a safe way.
I just want to say that on Sunday afternoon I'm giving a talk about a bunch of fun things you can do in XML that you really ought not to do in XML.
Yeah, so I'll come to that talk. But anyway, so last but not least is actually an oldie but a goodie, is that if you're unpacking a tar file from an untrusted source, basically if they put in a malicious path there, they're going to be able to overwrite any file that you can write to, which is something that has also happened in OpenStack, and it was the first advisory the vulnerability management team ever issued. So it's interesting, I guess, that despite the fact that there's all these warnings and a couple more here, that my favourites is the use of pickle and not creating secure temp files. But these things keep on popping up and coming up on my desk, and I'm just kind of always wondering, like, why don't people know about this? Like, it's there in the documentation. But then, in preparation, I thought that maybe I'm being a bit harsh. Maybe people do read the documentation and always want to do the right thing. So in preparation for this talk, I thought I'll just do a quick check, because I know when I'm writing some Python code, not all the time I'll refer to the website. I'll just look at the help in the REPL or go PyDoc to see what the actual calls are. And so this little script looks through the Python documentation that you can you'll receive if you in the shell type PyDoc or within the REPL, and looks for some of the nasty words that are in those warnings. And what I found was that in all of those modules that I mentioned just previously, none of the warnings were present in that documentation. And that's maybe something that we need to look at fixing in Python. I'm sorry, there was one case, it was make temp, says quite clearly that this function is unsafe and it should not be used. So that's a pretty good warning, right? So I'm going to wrap it up there. My final comments is that, I think as an open source project, OpenStack does a really good job of managing vulnerabilities. And I'm not saying that just because I'm on part of the vulnerability management team. I really think we do a good job comparatively to others. But obviously, if you've taken anything away from that talk, there's still a lot of things that we need to do to improve the security, and we need your help. So if you're a security guy and you're interested in helping out, one of the things that I didn't really have enough time to cover as much as I'd like was the good work that the OpenStack Security group do. So that's a much larger group of guys that are interested in security. They do a range of different things trying to proactively improve the security of all the OpenStack projects. So if you're interested in getting involved in that type of stuff, there's the IRC channel and the mailing list. Just pop us a note, and there's heaps of cool, interesting security projects that are all Python based that you can get involved with. And that's it.